Okay, moving on to Eg8. A 10 kilogram trunk lies on a rough horizontal floor. So we've got horizontal floor again. There's my 10 kilogram trunk. So that will have a weight of 10g, and it will have a normal reaction. The coefficient of friction between the trunk and the floor is √3/4. Calculate the magnitude of the force which is necessary to pull the trunk horizontally if P is applied horizontally or at 30 degrees above the horizontal. So in the first instance, we'll have a pulling force acting in that direction, and the frictional force will pull to oppose that. If it's going to move, it's going to move in that direction. So I'm going to take plus x and plus y to be parallel and perpendicular to the plane. And we know that mu is √3/4. So let's set up our equations first of all. So no motion in the vertical direction, so the sum of the y components is going to equal 0, and that's straightforward. R minus 10g equals 0. Then we know that F max equals mu n, and we know that at the point of moving, which is limiting equilibrium, so it's at the point of moving but it won't have moved yet, then there's going to be no motion, and P minus F max is going to equal 0. So from 1, n is 10g. In 2, the maximum value that frictional force can take is going to be √3/4 times 10g, and from that, in 3, the pulling force that is necessary to move that is going to be F max. So 10 a √3/4, so 42.4. Two significant figures because we've used G. So that's part A. Now for part B, what changes is that is now going to act at an angle, so it will have a horizontal and a vertical part to it. So just to keep it clear, let's quickly redraw the diagram. So now we're going to have a 30-degree angle, P. We're still going to have a 10g weight and a normal reaction, and we're going to have the frictional force there. So now when we resolve, first of all, let's do the y components. there's still going to be no upward movement, so it's not going to lift off the surface, so they're still going to sum to 0, n, and then we're going to have a plus p, opposite is sine 30 minus 10g equals 0. The horizontal summation is also going to be, are we trying to calculate it? No, we're not trying to calculate the acceleration, are we? No. So the sum of the x forces is going to also equal 0. P cos 30 is the horizontal component there, minus F, no other horizontal components, so that equals 0. And F max equals mu n. So those are my three equations. I'm trying to find P. So in order to work out P, I can first of all get N from there to get F in terms of P, and then replace the F within that, and that will give me the equation that I need. So just get some more paper. So from from 1, n equals 10g minus p sine 30. Put that into 3 and I get my F max at limit and equilibrium. The F max is going to be root 3 over 4 10g minus p sine 30, and then if I replace that F into equation 2, I have p cos 30 minus F, which is that, g minus p sine 30 equals 0. So I want to get P on its own, so I've got some work to do here in order to do that. If I first of all, what can I do? Well, I can multiply throughout by 4. Lots of different ways of doing this. Zero times 4 is 0, so that stays the same. So I've got rid of the 4 from the denominator by multiplying that by 4, that by 4, and that by 4. Now get rid of the rest of the bracket. So that times that is 10g root 3, minus times a minus is a plus root 3p sine 30 equals 0. So that's come down. I've expanded that by multiplying in the minus root 3, so that becomes a plus. There you go. If I now isolate on the left hand side the two terms that contain a p, and take the other one so that it's on the right hand side, I can then take P out of that as a common factor. And then to get the P on its own, I just divide by that. On our super duper calculators, we can put that in as we've written it. So fraction 10a, remember I store my 9.8, there isn't a g, so as a, root 3 as the numerator, and then as the denominator I've got 4 cos 30 plus root 3 sine 30, close bracket. Where have I gone wrong there? I need an extra, I've got 1, 2, 3 open brackets and 1, 2 close brackets, so that needs another close bracket. So P comes out to be 36.2. Which is different from G root 3 all over 4 cos 30 plus root 3 and 30. Okay, I get that to be 36.2. Last time I worked it out I had a different value. I can't see what I've done wrong there. So if when I work that out in class tomorrow I get the same answer, I'll stick with that, otherwise I'll re-record it. So that's P. Okay, as an addendum I've just immediately seen what I've done wrong, which is that when I've typed that root 3 in there, I've also brought the sine 30 into there as well. So if I type that in again, so fraction 10a root 3, and then underneath 4 cos 30 plus root 3 sine 30 double close bracket, and then I get 39.2, which is the same as last time I did that one. So it's 39.2 newtons. Again, we've got a G in there, so that's 39 newtons to 2 significant figures.